Good morning. It's my pleasure to represent ONF, the place where SDN and NFV, mostly SDN, started out of Stanford. So, and I'm delighted that SDNFV Tech Conference has invited us to be the first keynote. Also, thank you, the organizing committee, for having a wonderful ONOS and CORD workshop and many summits yesterday. As Mr. Dong said, it was overflowing, standing room only. There were 70 seats. There were 50 plus people at the back standing throughout the day, which is amazing. That really means that SDNFV has got a foothold in China in a big way. Right? And we support, obviously, we have big partners of ONF, China Unicom, Huawei, and China Mobile is a tier 2 partner, and we are hoping that a lot more people from China will join. So what I'm going to be talking about today, by the way, again, I'm Aseem Parikh. I run solutions and partnerships at ONF. Basically, think of that as a product management person bringing use cases from the industry back into the technical community of CORD and ONOS, and building solutions which the industry needs in the short term, mid-term, and long term. Okay. I'll specifically talk about one project, which is CORD, which has got the most amazing momentum in the network industry, and the ability of transforming the industry as we know it today is maximum. But before I do that, I want to also spend a little time talking about ONF and the new ONF, which has come about over the last 12 months by merger of the two organizations which you know, which are listed here, the old ONF and ON Lab. Okay, so before we do that, kind of give you a perspective of the problem we have created. So SDNFV has come a long way in 4 years. There are monolithic systems which we have broken apart into what we call the disaggregated, virtualized, component-based network. Okay, it has some VNFs, controllers, open source, closed source, proprietary, and white boxes, gray boxes, black boxes. And all of these disaggregated network components are what we are trying to build into a new network which will serve us for the next 50 years. The problem today is, where are we now? Operators need integrated solutions to be created out of this building blocks, this Lego blocks, so that they make sense to deploy and to start using to generate revenue, provide services, and so on and so forth. So this is a realization which we went through, that after 4 years, we have created maybe a problem, not a solution yet. And that's what we are trying to address. So that's what the new ONF's charter is to realize the potential of SDN and NFV with open source solutions. The solutions being a key part, not components, not frameworks, not platforms, but solutions. And from those solutions, from those reference implementation, create software-defined standards. So we are kind of going back to the old ways of doing standards. If anyone participated in IETF and RFC creation, there was a reference implementation done. Then once the reference implementation worked across multiple installations, you created an RFC, and that became a standard. That's how TCP/IP started. We are going back to those same principles and saying, let's create a solution, let's create a reference implementation using components which are available either in the proprietary components or open source components, put them together, and then define well-defined standards between them. And examples of that are obviously OpenFlow and P4 and others which are coming down, and we'll talk about that. So ONF, the champions of SDN standards, OpenFlow, and ON Lab have merged together to create these solutions. We have talked about the SDN NFV industry needing these solutions to really utilize and make money from the new revolution. But why is this the right time to do it? The right time to do this is because there are technology trends which are forcing the telecom industry to evolve, to mature. And those are, obviously, everyone has heard of 5G coming in 12, 18, 24 months, depending on which carrier you talk to. Internet of Things is a major trend which is going to change the way you build networks of tomorrow. And then connected cars, virtual reality, augmented reality are all these trends. So these trends are forcing us to think about the world differently. And we think that ONF has a role to play in kind of defining one path, if not the only path, but one path forward in that direction. So to make this work and to talk about those building blocks, we want to make sure that no one vendor has to build the whole stack to build a solution. That was the old monolithic way of doing things. We believe that the much more efficient, much more agile way of doing it is having different stacks, from the programmable forwarding plane, the controller, VNFs, services, and solutions built by people contributing different sets of IP, intellectual property, which can be all plugged together. So what we have created is this open innovation pipeline, which allows you to plug in your IP, your component, your innovation into something which can be taken directly into the market without your having to build the whole thing. Then to make sure that these components talk to each other again, the software-defined standards would be created so that you can replace component X with equivalent component Y of the same functionality, maybe from a preferred vendor, maybe with a couple of extra features and bells and whistles, which will allow you to differentiate your service as an operator. And lastly, the solutions have to be easier to build, customize, and consume. Consumption of these solutions is maybe the biggest driver, which we are focused on. Because if you make very, very difficult solutions to consume, the adoption is going to be difficult. So where we have played a role is we have defined one reference implementation for the control plane. We call that ONOS, Open Network Operating System. One implementation of this platform on which access solutions can be built, and we are only focused on the access, the edge of the network, and we'll talk about that. That's CORD, Central Office Re-architected as a Data Center. And on top of that, we have built 3 or 4 different vertical references solutions: Mobile CORD, M-CORD, R-CORD is Residential CORD, and E is Edge as Enterprise CORD. This is not by no means the only way of solving this problem. So we expect that if some vendors want to bring in their own controller, they are allowed to bring that in and replace from the reference implementation ONOS with that controller. It can be ODL, it can be a proprietary controller. Similarly, you can build another automation, another VIM, virtual infrastructure management component. Instead of OpenStack, you can bring in OpenNebula. Some of our partners, Telefonica in the room, have done that. So this allows you to go and take different components, bring it to the market. But we have created multiple innovation pipelines where people can plug in. And depending on whether you are a mobile, radio, RAN expert, you can bring in expertise there. You can talk through an XRAN protocol up to a programmable forwarding plane. And now you can connect up all the way into one of the service providers listed here, who are our partners: AT&T, China Mobile, Comcast, Google, so on and so forth. Okay, so the last slide about ONF. So the vision is, again, to transform operator network business models with open source solutions. But the idea is, the strategy is to do it the reverse way. We build it first, and then we prove it by deploying it through our partners and our early adopters into actual networks. That gives us confidence that this is the right path forward. This really solves the problem the industry is looking for. And then we have our ecosystem, vendors, productize it. And it's very important to understand that ONF is not in the business of selling solutions to the market. It is vendors and our ecosystem partners who will take the solutions, productize them, support them and take them to the commercial place. So service providers like China Unicom, China Mobile, China Telecom, BT can buy them from vendors, not from ONF. ONF doesn't have a price list of anything, okay? All right, so that was ONF. Next, I'm going to talk briefly about CORD. And this is maybe the most fundamental. It's a use case of an SDN application in the edge, central office re-architected to the data center. And the motivation is central office, or the edge of the network, of a service provider network, is obviously the gateway to all of the service provider's customers. There are thousands of COs in a typical country. China has maybe tens of thousands. And it is a source of the highest source of CapEx and OpEx, because obviously the number, if you multiply every dollar you spend and you have to do it 10,000 times, the CapEx and OpEx grows very, very fast. It supports tens of thousands of paying customers, residential customers, mobile customers, subscribers, enterprise customers. And it gives you a great vantage point to provide new services. So this is a place, if you were to install a new service, this is the place where it is being impacted. So this is where we thought that the new things we talked about, AR, VR, IoT, 5G, where a lot of edge compute is going to be required to reduce the delay, the round-trip delay between the subscriber system and your NOC or whatever have you running in the data centers. It is a place where we should need to implement some level of edge computing. And that's why CORD was focused on reimagining the central office. So the concept was very simple. If Alibaba or a Google or a Facebook were to build a central office today with today's technology, not 50 years old technology, what would they do? And that's where we brought in the cloud, SDN and NFV concepts together, and we wanted to identify a way of creating economies of data center where you are creating lots and lots of compute, lots and lots of access at a very reasonable cost, with the agility of a cloud provider, the OTT vendors, Alibabas, the Baidus. How do they bring out new services, the WeChats? How do they bring out services every week without having to impact the whole network? The service provider industry traditionally has had a very hard time introducing new services. It takes 6, 12, 18 months sometimes to introduce a new service. And why is that? So we thought this was an important differentiation between the OTT carriers so that we can bring those economies down to there. So, and how do we do this? So we do everything as a service. Everything is containerized, everything is virtualized, everything is disaggregated, and it is done as a service. This is maybe the most important part, where then you can constitute the service as a service chain or a service graph, as we call it, across the whole domain. So the architecture looks very much like this. You have all kinds of access available. We call this a multi-access architecture. Residential, mobility, enterprise services. There's an access service orchestration and control layer in the middle, which uses the hardware which is in the central office. So what's shown below here is the central office. If you look at the purple boxes, they are primary x86 servers, off-the-shelf servers, nothing fancy about them. This is where most of your compute storage runs. The difference between a data center and a CO is the boxes in the gold or the yellow. That's where the access comes in. So these are specialized hardware, again, ideally using merchant silicon and commodity hardware, which will do your broadband, your optical networking, passive optical networking for broadband services, as well as radio access networks using BBUs or have you. And then on the other side is the ROADM, which connects back to the core from the access, and that's where we have also disaggregated the ROADM and brought it up down into different pieces where you can realize that using merchant silicon. All the switching and the fabric in the middle is composed in our reference implementation of a white box with merchant silicon. There are only a few merchant silicon vendors available today. Everyone uses them, whether you go to vendor X, vendor Y, vendor Z. So why not create a solution, at least in the reference implementation, and you as a service provider can decide to use either that reference implementation or go and tell your favorite vendor to create a solution which is compatible with it. Okay, so here is the potential of disruption and transformation. You take a wireline packet switch, and what we have done is created this disaggregated virtualized version which talks down using OpenFlow or P4 to the fabric and has now converted that into a bunch of software running on this commoditized hardware. Similarly, on the mobility side, we have taken the eNode B and broken that down into a BBU, a programmable BBU, a virtual BBU, and using that XRAN protocol, we have created a way of managing this in a very, very modular way and scaling it up and down as required. You can go from a few hundred subscribers to a few 100,000 subscribers using the same architecture, just scaling it out using the hardware and software components. Similarly, on the OLT side, the residential broadband, we have taken an integrated control and data plane hardware unit and broken it down into Volta. Volta is a virtual OLT hardware abstraction. We have used that concept and created virtualized versions of all the services which are listed on the bottom here, and then talking to a OCP compliant GPON or a GFAST device. Which will then be programmed either through a Volta over OpenConfig and Yang and NetConf. So the key takeaway here is each of these three verticals is more than $1 billion of optimization opportunity. Every one of these, if you go to any large vendor, AT&T, BT, China Mobile, China Telecom, China Unicom, this is they spend $1 billion every year on delivering the services year after year. This is where you can bring that down significantly. And I don't know the number, it's maybe 30%, whether it's 50%, whether it's 75%, you can be the judge, but this is an opportunity which you can optimize. So given the amazing amount of value this is creating, it is no surprise that CORD is growing a lot of momentum. In fact, one survey came out earlier this year where 70% of all carriers who were asked the question, would you use CORD, said yes in the next few years. So this is an amazing thing. Out in here, China Unicom has already announced a trial with M-CORD, mobile CORD. This is reason. The first European Tier 1 service provider has come on board as a full partner for ONF and has a keen interest in R and M-CORD, and that's Deutsche Telekom, DT. We just announced this, in fact, last month. So this is wonderful, and heads up to all the European service providers. It's coming down your street. Okay? But the traction really is much more widespread. Every one of these people listed here in North America, in Asia, in Europe, have CORD pods in their labs today, working, some trying to get it up, some trying to innovate on it, some in fact contributing code back into CORD and ONOS today. So this is not trivial. The amount of people you see, I think 90% of the world's subscribers are connected to one of these service providers. Okay, so and this interest keeps on growing on the monthly basis. So bringing it back to China, in China we have created a China CORD Alliance, with help from China Unicom. Today we have 15 active members, including service providers, equipment, silicon vendors, manufacturers, system integrators, certification labs, BII included, and research institutes. And we are focused on, this industry alliance is focused on solving the Chinese context, the problems in Chinese context which are obviously different than in North America and are different than in Europe. So this will customize CORD and its workings in the Chinese context. Okay, so to summarize, the key takeaway from my keynote is CORD delivers unprecedented transformation. Never before we have transformed the edge like this, and it creates this agile network operator's edge. We call that the multi-access edge because now you can connect your residential, your mobile, and your enterprise customers into the same infrastructure, the same platform, and based on running VNFs and different service graphs, you can enable different services for different customers. You don't need to build silos in your organization for mobile, for enterprise, for residential. And then there is obviously your NOC at the back, which can operate this through ONAP, OpenO, MANO, whatever your favorite global orchestration technology is, you can operate this whole network using that, and CORD would support the northbound like we talked about yesterday. All right, thank you very much for your time. Please join us as our community is 200 strong and growing. And you see the number of partners at the top level. The board is who is who of the networking industry, and we have 110 plus innovator members also. So thank you very much.